Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, everyone. Welcome back to another exciting edition of IT Pro TV. I am your host, Vaughn Smith, and this is our Cisco Cloud Fundamentals exam series. And in this episode, we're going to talk about storage access technologies. And here he is, the man with a plan, Mr. Ronnie Wong. How are you?
I am doing well, Vaughn. Thank you again for joining me as we continue on our Cisco adventure together here, right into the realm of cloud fundamentals. That's right. That means you are preparing for this exam, and we are here, of course, to help you to at least make sure you know what is going to be on the exam objectives and that we cover them in full detail. And so here we are, Vaughn. We are actually in the 5th domain out of 5 domains here. So we're getting pretty close to the end, but it also means that this is the area where we might have had some familiarity with. So if you checked out our last episode where we talked about the basics of the different technologies such as RAID and those ideas, we are now talking about the idea of access technologies. And this is where it gets a little bit beyond the person that just uses a regular PC computer or a laptop computer. This is now where we start talking about things like NASs and SANs briefly, and then we'll jump into the underlying technology as we move through this series. And then, of course, we'll actually jump into the Cisco-specific technology, which means we're getting more and more specific as we go through. So this is just a high-level general overview of some of the technology that we have to understand at the most basic level, and then we'll take those concepts and we'll break them apart even more, okay, and actually take a look at the underlying technology. So right away, one of the things that you want to make sure that you understand as we get started here, of course, is the idea of storage access itself, okay? So Vaughn, in the previous episode on storage, we talked about the technology of RAID arrays, okay? And we broke that down where we showed you how you could group those disks together. And the idea of grouping them together was for performance as well as fault tolerance.
Yeah, we did the striping and the mirroring and the parity, right? Where it puts the different things and how it brings it all back together.
A+ for you, Vaughn. Awesome. Yeah, so yeah, just those basic concepts. And we also talked about the idea here, right, of the nature of what we call thin provisioning and thick provisioning too in that previous episode. And we kind of made sure that you understood that because those are underlying technologies that really help when it comes to data centers and cloud as well. Now, even though those are kind of the basics in terms of storage that we want to talk about, remember, that's kind of the underlying technology. When we start moving into the realm of the cloud, all that is hidden from you and me, okay? So that means that what we do is we access it, okay? And the way that we access is actually important. So let's start off actually understanding, Vaughn, in terms of storage, most people really don't care if they're storing to a hard drive or not. And it's not because they don't care about hard drives, it's just that it really isn't a concern for them. They know that if they launch up a Windows computer and they store something, it's going to get stored somewhere. Traditionally on a regular desktop computer, it's going to get stored on their hard drive. Or if you're in a business environment, it may get stored in a logical structure that we call a folder, and that folder then is synced up to someplace else.
I think the biggest thing is just remembering where you put things.
That is still the biggest challenge for me. So unlike now Vaughn's really good at this. She knows how to actually structure folders and files and stuff. I have one big folder called downloads, which everything just ends up there because I'm too lazy to make additional structures. But I've seen Vaughn, she actually kind of separates out everything, which is great. I wish I actually had such a division and such a logic and adherence to structure myself.
Oh, don't worry. I think I actually get myself more lost sometimes doing that.
Yeah, but that structure is actually very important because, Vaughn, the whole goal behind most of the technology that we do is that idea of just making sure that we can access those individual things and data that we need to. Now, Vaughn, I'm avoiding the word file on purpose, okay? But that's what you and I tend to think about, right? So, Vaughn, we make a Word document, okay? We call it a document, but on the computer, we see it when we actually go into something like Explorer, or if you're actually in Windows, the Finder, right? If you go in there, we simply call them what? Files, okay, is what we call them. But a file is not technically just data itself, okay? And that's the key to understanding when we start talking about the idea of some of the storage technologies that we're about to get into, such as NAS and SANs and file storage and block storage. So those are some of the things that we want to be able to differentiate and understand as we move forward, okay? So let's go with the traditional idea that we understand first, okay, which is the idea of file storage, and then we'll go back and we'll talk about block storage and how that relates to RAID arrays as well, okay? So Vaughn, as we get started, let's go ahead and take a look at my screen, and this will, I hope, will help us out. So here's the traditional model, Vaughn, in terms of accessing files, okay? Now, when we talk about it, a lot of times, just like I said, normally the idea is actually just locally stored on that particular machine, and the user, they simply open up an application, they retrieve the file, it opens up in RAM, they can use that file, or they run an application, which again seems to be stored as multiple files that they can get access to. But Vaughn, with the idea of the files, the great thing about the idea of the files, though, is that it includes not only the data itself, right, but also the metadata that tells it how it's actually going to be reported back to us, okay? And that's what makes it nice and portable for us and makes it understandable across multiple machines too, okay? So we don't just throw data onto a drive and expect it to come back together as an individual file. We store them in files together, contiguous structure of essentially data that we store, and then we add in metadata to that, so that file, when it actually is called upon, it knows exactly how to come back together. So this is the most traditional way, but it's also the most limiting way too, Vaughn. If it's stored here, well, the way it used to be is we called it sneakernet, right? Vaughn, if I said, hey, I need a copy of that file, well, you'd have to take a floppy disk. I know that may be a little bit beyond some of us here, okay? Take a floppy disk, copy that file from your hard drive on that disk, hand it off to me, and then I would put that disk into my computer and, of course, be able to pull up a copy of that, okay? So, Vaughn, one of the things that helped us out, right, as we started to change and started to realize that business was growing faster and that what we needed was to be able to get access to those files quickly, because, Vaughn, if you left for the weekend, okay, and I said, oh, I still need access to that file, well, Vaughn, if your laptop is off, if your desktop computer is off, and you've got it only stored on your own computer over here, well, even if I was on another computer, I can't gain access to it if your computer's off. So essentially, we started using what we called file servers. File servers are, of course, a server that is ultimately designed to be able to structure I shouldn't say structure, but be able to host files, okay? Now, technically, files themselves are actually called unstructured data because we can actually find that file wherever we want to on the hard drive. And it doesn't really matter so much exactly where it's stored because we can always use some utility that allows us to be able to search that drive and find the file, find the metadata, allows us to pull that up. So a lot of times when we talked about a file server, it was running an operating system. And then, of course, we could actually store our files in the folders that we wanted to. And that was what we called, shared folders that we would be accessible to from our users. Well, file servers themselves, they essentially were just another computer, which also made them relatively expensive too, but also had a limitation in terms of how many drives we could put into a server, for example, right? So if I ended up buying a server and there were only 6 drive bays in them, I might have actually taken 2 away from my operating system to mirror that so that the operating system would never be down, okay? Then I had 4 drives left that I might have also went ahead and put into an array, let's say a RAID 5 array, just for the sake of simplicity here, that I could store files on. But Vaughn, what if I actually needed more than what that combined storage was? Well, I wasn't able to actually add in any more into that file server because there was no more space for us. So essentially the development then moves on to what we call NASs, okay? Stands for Network Area Storage, or Network Attached Storage. Attached, I think, is actually the proper term here. So I don't know why I always say network area because I think I'm thinking about networking as more than anything else.
Well, yeah, because it's like almost LAN backwards.
Yeah.
But with an S.
Yeah.
So actually, no, it's
No,
not
not
really,
exactly,
just like-
yeah. But no, it's just because the word networking, and I always think about networking areas and stuff like that too. But this essentially gives us the same ability, but now instead of accessing just a single folder that resides pretty much on one file server up there, what we of course do is that we actually have a machine that has a dedicated operating system on it, and its one purpose, right, is not to be able to run programs so much, but to give you quick and easy file access across the network as well, okay? So it doesn't matter where you're attached as long as you're actually in the network. You, of course, actually get access to that. It's a shared array that has folder structures in there that you can then use to be able to gain access to it. So at the beginning here, we want to focus in on this idea when we start talking about the idea of NAS too, okay? So when we store things as files, what I mentioned here is that technically it's what we call unstructured data, okay? And that is because it is the data that's stored, but it has all the information and that needs to rebuild that when it's called up by a program, which is the metadata that we have on hand, okay? Now, in terms of the hardware basics, Vaughn, okay, Usually these NASs at the smallest end of them, because I remember we used to, at the very beginning, okay, of IT Pro TV, we had a simple NAS storage that we ended up buying because we were an incredibly small company. We were pinching pennies like crazy. We bought this NAS that could hold up to 4 hard drives, and we thought we were big stuff, okay? And the reason why is that those hard drives were 1.5 terabyte hard drives, and we thought, man, 6 terabytes, we'll never run out of space with 6 terabytes. And we didn't realize that it didn't take us but about 6 months before we were actually out of space. And I say 6 months, that's probably giving it at the large end of it. More than likely, it was about 4 months later when we realized that we were recording videos, and it didn't take much before we actually ran out of that space. But NASs, they don't have to actually come in small units like that. That's more of consumer grade, but they can actually consist of hundreds of hard drives. Then inside of that, we can also go ahead and essentially configure RAID arrays if we want to, or even the idea of storage pools too, okay? So we talked about this idea of RAID arrays before in the previous episode, where we showed you that you have some different ways that you can, of course, implement the idea of this redundant array of independent disks for us, or we can also group together all of the data in what we call a pool of storage if we want to, okay? Essentially just spanning the actual data. It helps us to increase the capacity that we can do. And the nice thing about most of those NASs, I shouldn't say every single NAS, but so like if you go for the consumer end, you'll see that there's a maximum size of a hard drive that you can put in there. Okay. So on those, like for us, we knew that the maximum size hard drives we could actually install in the ones that in the NAS that we ended up getting, I think was 2 terabytes. So we went with 1.5 because they were really, we thought there's no need to go for 2 terabytes. At that point, the 2 terabyte drives were kind of iffy in their performance and actually stability. So they would actually lose data a lot quicker. So for us, we went with 1.5, which were actually fairly standard at that point. Now, once we start actually, being able to then group them together and put them into a RAID array, that gives us faster performance. If we also did some type of implementation of parity, which again, RAID 5 gives us parity, it gave us the ability to recover from the failure of one of those disks, and we didn't really have to worry too much, okay? The other thing about it is we no longer have to worry about devices kind of turning on and off anymore. That NAS actually, was up and ready to go, and we just left it on all the time. So NASs can be relatively self-contained, or they can actually be devices that are actually spread out, among, gigantic devices here where they have hundreds of hard drives in them as well, okay? Now, the key here, though, Vaughn, in terms of NASs and the way that they're actually working, right, is that really you as the individual user, okay, using some type of desktop application, you're the one that's really accessing this, and that means that the way that it has to work is that you're not trying to do a lot besides get access to those files. So there has to be some type of formatting that goes on those drives, okay? Once we format those particular drives themselves, then because it's a network attached storage, this actually allows us to set it up as an individual computer sitting on the network, but then we just use regular common protocols that can allow us to access that storage. That means I didn't have to actually build something fancy. We didn't have to learn a new protocol to be able to access that particular device, nor to get access to those files so that I can retrieve them. We were actually simply able to actually start using things like NFS, right? The network file system that was actually available for us there, okay? And this is actually good if you were running things like Linux and Unix computers, okay? But you could also run things like SMB and also CIFS, the common, I can't remember what that actually stands for, Internet File Service. That's what I have to make sure. So you could actually even run those structures that was available to pretty much all Windows too. So those are not anything that's special or native to NASs. They're actually individual file systems that we can access from the network and be able to gain access that way instead. Okay. Now there are a ton of different manufacturers that make these devices. So the first one that I talked about here, that I was telling you about, again, the name of it was Drobo, if I remember correctly. That was one. But we actually had an older one that we were using before that point. That was a Buffalo Terror Station, is what it was. So you name it, we've actually gone through quite a bit of these NASs at times, that we've done. And today we still rely on a NAS for things like individual workstation backups too. Okay, so like I think Vaughn's computer actually backs up to our local NAS that we call the QNAP, So we like that. And it works very well, right?
Yeah. I mean,
Yeah.
it actually saved me really,
Yeah.
really nicely one time. Yeah. Yeah.
Yeah.
Time Machine is an awesome thing in the Macintosh world. And I didn't really care where I was putting it, right? I
Yeah.
just connected to it. They said, here's where you go ahead and tell the Time Machine preference. It's like, this is some group of numbers. And I said, okay. I make sure I put my backups on it, and
That's
it
the way it
just
goes.
works.
Yeah, so all that's actually kind of neat, right? The very fact that we can have those devices on our network that's up and operational all the time, and there's no other needed additional technology that needs to be implemented with it because it's not proprietary in how you access that technology. So a lot of different vendors are out there. Dell EMC is probably one of the big vendors, not only of NASs, but SANs that we're about to talk about briefly as well. And then, of course, there's another one out there that Cisco really has a great affinity for, which is a company that's called NetApp. Okay, they make these devices as well. IBM also makes one. LSI, I think it's IBM's for one reason or another. HP, and there's even more. You go out there and find it. There's actually even name brands that I've not heard of that make these types of devices. And for a small to medium-sized company, it may be all that we need. We don't really need the idea of any more than that, but we're trying to provide end users access to their particular files that they need. Okay, so it has that goal and structure of what we're actually talking about here. So when we start talking about file storage, though, there are a few different characteristics that you want to be familiar with. Okay, so Vaughn, instead I actually just made this table to try and help us to understand. So normally when we start accessing it, file storage, right, you've got a program that you're actually using at some point, but some of the examples of files that you might also do are things like ISOs, okay? That's really good for things like application that you might want to download and then install. Disk images, if you're still imaging regular desktop computers and having to bring that, these images are large and gigantic and they would normally eat up the space on some desktop user's hard drive. You don't want to do that either, okay? Individual files, right? You create a file structure that you want to. Nobody knows any different whether that's actually on their local machine or up in that, in that NAS as well. Okay, it looks like just another folder on their machine. And then VM templates are also good here too. Okay, now the provisioning, like we said, is really about the idea of making sure that people gain access to files. Performance is not really the key goal, right? It's just so that everybody can gain access to files. The data management itself is relatively simple because most people don't even know if you don't tell them. You just say, oh yeah, we've connected you to a network drive. If they're connected to a NAS, it just looks like just another folder on their desktop. That's another one. Of course, it just depends on what you need, but usually PC users or who access this. Servers, of course, can access this as well. But there's a couple of different storage devices, okay? There's the NAS itself, which includes, of course, your hard drives and everything in an enclosed device that has hard drives and then a basic network or a NAS operating system on it. Or you can have what they call a NAS head. I know it sounds funny, okay? But this is just a front end of a NAS, and those types of NAS heads here, which again is just a logical structure for you, they can connect into different RAID arrays and different devices to make it look like, well, multiple NASs are actually able to connect together and actually act as one unit if you wanted them to work too. The access protocols, like we mentioned, you can use NFS. Remember, we've already talked about that, as well as CIFS. The controls are just like we have as regular users, right? We can implement file permissions. So for us, read and write access, read-only access, right? Those are actually kind of the things here. The content and the way that we get access to it is through directories, and every file has metadata on it. And to scale, this can go gigantic. So yeah, I actually put huge on there because our president actually used that. I think it's a cool term myself, okay? So here it is, huge, but you get the idea.
When I first saw that, all I saw was Yugle.
Yeah,
I saw it as
Yugle.
an L, and I'm like,
Yeah.
I don't think I've ever heard of that. Is that
Yeah.
like a proprietary
Huge.
scale model?
Yeah.
I'll just wait for him to get there. I'm like, oh wait, that's an exclamation point.
Yeah.
You're being silly there, Ronnie.
I am, but it's just neat to not have to pronounce the actual letter H sometimes.
Oh, yeah. That I don't know about you, but that's one where I'm like, there's huge.
No, huge. That's the way you do it. All right, so that's the idea of the NAS. Now, those I'm super fairly familiar with because over the past decade and more, I've been using these devices, and we've always outgrown the NAS that we've had, Vaughn, always in every instance. And instead of actually replacing it with something that could actually be expandable a lot of times, right? We just kept saying, let's just buy this and let's just add this on. And the reason why is it didn't require a ton of setup, okay? That's why you actually add it in. You buy the device, Vaughn, I plug it in, I plug a network cable into it, I give an IP address, and that thing is off and ready to go, okay? Pretty much that's just the way it is. So it's neat how you can actually get that thing set up very quickly. And unless you're actually having to do a lot of permissions and stuff, it really is. This is probably one of the neatest things that's out there, where you just turn it on and within 5 minutes or so, things up and running. You can start putting folders up there, start sharing it out, and start doing all that stuff that you need to. So really neat in everything that it's doing. Okay. All right. So now we need to talk about the next device that also is along with this, and we're going to compare that, which is the idea of a SAN, which is a storage area network. Okay. Now a storage area network actually fits and looks pretty much the same. So Vaughn, you actually see that if I take a look at it, well, now notice that I don't have a file up here, Vaughn. Okay. So let me zoom in so that we can see that a little bit better. Okay. I'll just move that over and then we'll get to the details a little bit more. Okay. So on the left-hand side, we're no longer accessing files on this. Now, can you access files? Yes. But essentially what a SAN does is it slices a portion of the capacity off, and then when it actually reveals itself to a regular user, they look like that they have access to another hard drive, okay, to a hard drive. They have access to the whole thing, and they control all the blocks of information that's written there. So it doesn't matter if it's actually stored locally, but that's what it looks like to them. It normally is going to be stored on what we call that storage area network, okay? So it essentially abstracts all of this, and we can write, again, a 1 terabyte type of block across this, and even do a thin or thick provisioning. It doesn't matter. So I'm trying to combine things together for you. Okay. And what we're doing is we're striping essentially blocks of the chunks that we have here, the full capacity. Okay. And it abstracts it to where the end user just sees that they have access to a volume of storage is what they have access to. So notice I actually duplicated this because people kind of confuse this. So it's the same thing. So now instead, it's exactly the same. It doesn't matter how you gain access to it. So it's not any different. I just kept the same exact model, whereas before, when I did file storage over here, I kind of had a file server before. Well, we actually kind of dropped out of the file server realm, and we just simply went directly to SANs, and then that's what happens here too. Okay. Now we're going to get a lot more into the SAN technology, but Vaughn, the big thing behind this, okay, is the contrast here. Okay, the contrast is this requires some setup. You can't just buy this thing, plug power into it, put a network cable to it, and go work. Okay, this one requires a bit of setup to make it work, and we're going to be talking about probably the 2 major protocols in pretty good depth. I say a big overview, I should say. Okay, so that we can at least understand. Okay, so Vaughn, what are some of the characteristics here? This time we are provisioning volumes at a time. That's why this looks like a hard drive to the local user. We're not provisioning individual files where they can actually gain access to it. We're saying, here's the space you have access to, and it looks like another volume. Okay, performance here is pretty high, and that's because we really do. We actually implement things like the RAID 1 plus 0, the RAID 0 plus 1, the RAID 6s, the RAID 5s if we want to, but today people don't recommend RAID 5. Okay, management here is complex. Okay, depending on the underlying technology, it can be really complex, and it can be really expensive. Okay, so usually the 2 big ones here that you see in terms of the access protocols, these are more proprietary. Okay, now Internet SCSI is not as proprietary. Fiber channel is super proprietary here. Okay, so the storage devices are what we call SANs. We normally do not access them as individual users. Servers essentially are the ones that connect and go, oh, here's a hard drive that I have access to, but they don't know exactly where that is. Okay, the controls though, notice that they start to use the idea here of what we call LUN masking, and the idea here, of course, of LUN zoning. Okay, LUN zoning helps us to be able to say how much we're actually going to use here, and the masking is just presenting that to the user as well. There is no content control because we're not worried about the content because you're the one that's managing what gets stored in that particular one here. And this time you don't scale as much as the idea of the NAS here. Okay, you can only scale bigly. I've heard those 2 terms, so I like them. I like it. I'm
do. Liking it, Ronnie.
Yeah, I like it. I thought it was, I was like, yeah, you don't scale it big, you scale it bigly, kind of big, but big, and then any files, databases, data, and this is kind of weird. So for us, we can do files. You can do any type of storage that you want to. But the weird thing is about databases, Vaughn. So like for us, if we build an Access database, the whole thing is stored as an individual file. But in reality, right, a database doesn't store things like that. It stores things in huge amounts of structure is what it does. So on blocks of storage, you have to actually have everything kind of structured the way that you need to in terms of those blocks to make sure. So this can actually house any type of data that you want to. And this is probably what is more prominent when we start talking about the idea of cloud technology, is making sure that we understand that particular portion of it as well. Now, as far as SANs go, there are many different types of SANs as well. Okay. Now, we're not actually going to jump into all the different types of SANs right away, but what we're going to do is we want to at least talk about a little bit, right? So in the next episode, we're going to go over the idea of storage block or block storage access, and we're going to be talking about the idea of different types of SANs just briefly here, but we're going to focus in on probably the most popular type as well. So probably the most popular one is what we call FCP, which is Fiber Channel Protocol. It's probably the simplest one as well, but the one that's probably the most implemented one, okay, and it's probably it's not the most popular. Most popular uses that proprietary technology that we call Fiber Channel, but iSCSI is actually probably even more popular. The reason why, Vaughn, is it doesn't cost a ton of money, but we are also limited by the very fact that it's running over IP, okay? So in this one, iSCSI is actually, again, the Internet Small Computer System Interface, and the SCSI commands actually end up inside of the Ether channel frame and uses the entire IP network to do the transport of the data that we need to. Whereas in Fiber Channel, everything is actually transported and transmitted and, of course, encapsulated inside of, Fiber Channel, okay, is what it does. Then there's also Fiber Channel over Ethernet. This works like iSCSI does, except instead of using IP as a transport layer, it stays on the Ethernet layer, another layer 2 to transport all the data. So this is actually very fast and very much proprietary. And of course, probably the latest one is Fiber Channel over NVMe, okay? The non-volatile memory express over Fiber Channel. And this, is, of course, is actually probably the latest one that we can actually implement, and that means flash-based storage, okay? So all those different storage types that are out there, we're going to talk about the simplest of them, because the Fiber Channel itself, that's a technology that, yes, you're going to be tested on the exam. I'm not going to tell you that there's 15 questions on it. I can't tell you that. But I think you'll actually be surprised that you'll see a couple of different questions on the idea of Fiber Channel. So we'll make sure that we spend some time there too. All right, Vaughn. Well, that is going to be our brief overview. Now, even though the actual overall topic, though, according to the exam objectives, Vaughn, it calls out making sure we can differentiate between NASs and SANs, but also block and file storage. Well, we're about to go ahead and separate out that idea of what we call the idea of block access storage, or make sure I'm telling you, block storage access first. We're going to make sure that you understand what that is, to a good point, because there's many different technologies we need to cover there, but we're going to spend the majority of our time taking a look at the idea of Fiber Channel is what we're going to end up doing. So, Vaughn, let's go ahead and do that. Since this is kind of a high-level overview where we've actually done that, we still need to go on, and then now we're actually kind of divide that up and dive a little bit deeper into each one of these technologies here.
All right, Ronnie. Well, thank you so much. That's a huge thank you for you and all your knowledge, and a bigly thank you for you guys for joining in. But we're going to go ahead and sign off. For IT Pro TV, I've been your host, Vaughn Smith.
And I'm Ronnie Wong.
We'll see you soon.
Thank you for watching IT Pro TV.